Finding a missing and duplicate number looks like a job for a hash map, but there's a cyclic sort trick that lets us solve this in place without any extra memory. We're given an array that should contain all numbers from 1 up to the length of the array. However, one number is missing and another is duplicated. Our goal is to return both. For example, if we have an array with 1, 2, 2, and 4, we can see that 2 appears twice and 3 is completely missing. We need to identify that 2 is the duplicate and 3 is the missing value. The most basic approach is to use nested loops to compare every single pair of elements to find the duplicate, and then use the mathematical sum of a series to figure out what's missing. While this works, it's inefficient because it takes quadratic time, specifically O of n squared, and it's simply too slow for larger datasets where a linear solution is expected. The key insight here is that in a perfect array, every number belongs at the index equal to its value minus 1. We iterate through the array, and if the current number isn't at its correct position, we swap it with the number that is currently occupying its rightful spot. We keep swapping until the current index holds the correct value, or we find a duplicate. Once the sorting is done, we do one final pass. Any index that doesn't match its expected value reveals both the duplicate and the missing number simultaneously. You'll recognize this pattern whenever a problem involves an array containing numbers in a specific range, like 1 to n, and asks you to find missing or duplicate elements. This approach runs in linear time because each element is moved to its correct position at most once. The space complexity is constant since we modify the array in place. Try the first missing positive problem next. It uses this exact same pattern. Subscribe for more deep dives into DSA patterns.